Now let's go through some examples of polynomial division. Now polynomial division is a long process, has a lot of steps, and I'm going to go through it pretty slowly just so we're all keeping up and on the same page. If you feel like you can go a little faster, move ahead a little bit, that's fine. Just make sure you're being really careful about signs and subtraction and all those things as you go through. So you can go faster, just make sure you're not going fast enough that you're going to be messing those things up. Because if you make a mistake at the beginning, you have to go all the way back to the beginning to fix it and basically do it all over again. So it makes much more sense to take it slow and not mess up than it does to have to go back and do the whole problem over again. Let's look at this example as our first one. So notice I have a rational function here, or a polynomial divided by a polynomial. And so the polynomial on top is my dividend, that's what I'm dividing into. The bottom is my divisor, that's what I'm dividing by. So when I set up the division, it looks just like traditional long division, except the one major difference is that I leave a plus 0 anywhere that I don't have a term to fill in. So notice I have an x cubed, x squared, x term, but no constant term. So I'm going to add a plus 0 for my constant. If I was missing another term, I'd put a plus 0 in there too. So my goal is to be able to cancel this x cubed by subtracting off another x cubed. And in order to get an x cubed from this x, I'm going to need to multiply it by x squared. So I multiply this x squared times each term here. So x squared times x gives me x cubed. X squared times 2 gives me plus 2x squared. And then I need to subtract off that whole piece. And I need to be careful with the subtraction. This is where things get a little tricky. So I have x cubed minus x cubed. That comes out to 0, which is what we wanted. That was our original goal. And then we have 3x squared minus 2x squared. So we just end up with plus x squared. So this is where you kind of have to slow down, be really careful. We can bring everything else down now. So now we've done one step of polynomial division. So basically what this tells me is if I look at this equation, I could rewrite it as x plus 2 times x squared and then add this. This is what we call the remainder. So now I want to do this again. I want to repeat the process. So in order to get x squared to cancel with the x, I need to multiply the x by x. So x times x gives me x squared, then the plus 2x goes there. So x squared minus x squared cancels, so that's good, that's what we wanted. We have minus 4x minus 2x will give us a minus 6x. And I can bring down the plus 0. Now we've finished a second step of polynomial division. So I could rewrite this original function, this original polynomial, as x plus 2 times x squared plus x plus the remainder of minus 6x. But I have one more step I can do because my remainder does not have a higher or a lower degree than my divisor does yet. So I can multiply the x by negative 6 to get a negative 6x here. Then I need to multiply the 2 by negative 6x also. I'll get a negative 12. And I subtract off that whole thing. This is where a subtraction gets really tricky. So negative x minus negative x is 0. Minus 6x minus negative 6x. And then I have 0 minus negative 12, which will give me a plus 12. Now we see our remainder has a lower degree than our divisor does. So we're done. So what we want to do is we can rewrite this. So there's our answer from our traditional division. That's where we would have it. And then I just add my remainder and divide it by the divisor. So that would be my answer to this division. Now let's look at number 2, the second example here. Notice that every term is here in this case, so I don't have to worry about adding in zeros as placeholders. Also notice that I have a 2 as my leading coefficient, or the coefficient with my highest term. So I'm just going to have to be careful of that when I actually go through to cancel this term. So I set up my division. So in order to get a 2x squared here, sorry, a 2x cubed here so I can cancel, I'm going to need to multiply that x by 2 and then by x squared. So 2x squared times x will give us 2x cubed, and then 2x squared times negative 1 will be minus 2x squared. So we get 2x cubed minus 2x cubed, so that becomes 0, so that's our first good step. Then I have minus 4x squared minus negative 2x squared, so that I'm adding 2x squared to negative 4x squared. I'm going to end up with minus 2x squared, and then bring down the rest. So again, I've done one step. I could rewrite this equation as this times this plus all of this. Now I need to cancel out this negative 2x squared, so I need to multiply the x by negative 2 in order to get negative 2x squared. So negative 2x times x gives me negative 2x squared. Negative 2x times negative 1 gives me plus 2x. And again, subtract all this off. These will cancel, just like we want them to. Then I have 5x minus 2x, so I get a plus 3x. And then bring down my minus 3. So in order to get something that will cancel here with the 3x, I need to multiply the x by 3. So 3 times x gives me 3x. 3 times negative 1 gives me minus 3. So what I end up with is 0. 3x minus 3x gives me 0. Negative 3 minus negative 3 gives me 0. That means that this is actually a case where we have even division. This goes into this an even number of times, or evenly, not an even number of times necessarily, but evenly. So our answer is just what's here. There's no remainder in this case. Let's try another example. Let's take x cubed minus 3x squared plus 2x plus 1. And I want to divide it by x squared plus 1. So what I've changed here is that we're no longer dividing by a first degree polynomial, we're dividing by a second degree polynomial. It really doesn't change anything, it's just going to make the process a tiny bit longer. So let's set up our division. Again, I don't need any zeros, I have all my terms, except notice that I forgot to leave a 0 over here. So let's do that. Okay, that looks better. So in order to get my x cubed to cancel here, I need to multiply x squared by x. So notice I'm going to line that up way over above my 2x in my x's column. So x times x squared gives me x cubed. X times 0x will give me 0x squared, and x times 1 will just give me plus x. And again, I need to subtract all of that away. So x cubed minus x cubed cancels. It's good, good start. Then minus 3x squared minus 0x is still going to be minus 3x squared. And then 2x minus x is going to be x. Then I can bring down my 1. Now I can multiply my x squared by negative 3 to get the negative 3x squared to cancel. So negative 3 times x squared plus negative 3 times 0x will stay as 0x. And then negative 3 times 1 will become negative 3. So again, subtract off. Negative 3x squared minus negative 3x squared gives me 0. X minus 0x gives me just x. And then I have 1 minus negative 3. So I get, 1 plus 3, which is 4, not 5. So notice now my remainder, what I have left here, has a lower degree than my divisor does. That means we're done. So our remainder this time is not just a number, but actually has an x in it. And that's one of the major things that will change when we start dividing by second-degree polynomials instead of first-degree polynomials. So our answer here will be x minus 3 plus this remainder divided by the divisor. So there we go. Let's look at this example. Let's take x cubed minus 3x, and we'll divide that by x squared plus 1. So we're still going to divide by a second-degree polynomial. So when we set this up, so again, I'm missing my zeros here. I should be putting in zeros. I'm going to need quite a few of them here because I'm missing quite a few terms. So I have 3 different places where I have to fill in with zeros as placeholders. Okay, so in order to get the x cubes to cancel, I need to multiply this by x. So that goes all the way over in my x's column. So x times x squared gives me x cubed, x times 0x gives me 0x squared, and x times 1 gives me x. So x cubed minus x cubed gives me 0, like I wanted. 0x squared minus 0x squared is going to stay as 0x squared. And we can actually just treat this like it's not even there. So our first term isn't even going to involve an x squared. And then we have minus 3x minus x will give us minus 4x. And I'll bring down my plus 0. So if I had left my x squared here, then I could go through and say that I need to multiply x squared by 0 to get 0x squared. I'd go through, I'd find that this whole term will become 0, I'm subtracting 0, I'll end up with exactly the same thing. So we don't need to worry about that 0 because it doesn't change anything. But we do see that once we've gotten to here, our remainder has a lower degree than our divisor. So we're done. This is our remainder. So our answer here is going to be x plus negative 4x divided by x squared plus 1. Okay. One more example. So let's take x cubed plus 3x squared plus 3x plus 1, and I want to divide that by x plus 1. So we're going back to first degree divisors here. So let's set it up. So I need to multiply x by x squared to get my x cubed. X squared. So I get x cubed plus 1 times x squared, or just x squared. So x cubed minus x cubed cancel. I have 3x squared minus x squared, so I end up with plus 2x squared, and then I can bring down my plus 3x plus 1. Now, in order to cancel this 2x squared, I need to multiply x by 2x. So 2x times x gives me 2x squared. 2x times 1 gives me 2x. So when I subtract this away, the 2x squareds cancel. Then I have 3x minus 2x. So that's just x. I can bring down my plus 1. Now notice that I can just multiply the x times 1. So I get x times 1 is just x, 1 times 1 is just 1. When I subtract that, the whole thing is going to become 0. So again, in this case, we have a situation where the divisor divides evenly into the dividend. So our answer here would be x squared plus 2x plus 1. Now, if you happen to be comfortable with factored forms, you may recognize that x cubed plus 3x squared plus 3x plus 1 is actually the same thing as writing x plus 1 cubed. So when we divide x plus 1 cubed by x plus 1, we're just canceling away one factor of x plus 1. So what we're left with is x plus 1 squared. Well, when we square this, if we actually multiply it out, we get x squared plus 2x plus 1, which we can see is exactly the same thing we got doing the long division way. So we can see that factoring and division, polynomial division, work nicely together.